Good afternoon, class. Here's Chapter 4, Application of Derivatives. Section 4.6, Antiderivatives, Antidifferentiation, also known as integration. Integration or anti-differentiation is the reverse process of differentiation. So we are going to start with this, and just as we did with differentiation, when we integrate a polynomial, we do them term by term, starting with the first one. We add 1 to 4 becomes 5, and we divide by 2 over 5 x to the power of 5. So in essence, you're using the power rule. Over here, the exponent is 3. We add 1, becomes 4, and we divide by it, plus 3/4 x to the power of 4. This one, the exponent is 2. We add 1 and divide by it, minus 7/3 x cubed. X, the exponent is 1. We add 1 to it, becomes 2, and we divide by it, plus 1/2 x squared. Finally, minus 5x and a constant. And that's the final answer. The integral of x minus 5 quantity squared dx. First, we use our algebraic technique of finding a minus b squared, which is a squared, minus 2ab plus b squared. Therefore, over here, we get x squared minus 10x plus 25. In other words, expanded. And then term by term, this is 2. So again, we're going to go with the power rule. We add 1 and we divide by it, 1/3 x cubed. This one, the exponent is 1. We add 1 becomes 2, and we divide by it. Negative 10 divided by 2, negative 5x squared. Plus 25x and a constant. So the final answer, 1/3 x cubed minus 5x squared plus 25x plus c. What happens here? Even with the differentiation, the first step would be the same, meaning we are going to make up 3 fractions. X squared divided by x squared, which is 1, minus 7x over x squared, which is minus 7 over x, and 2 over x squared. So there are 3 fractions. To get this ready for integration, this one is intact. We're going to write this as minus 7 times 1 over x, and this one 2x to the power of negative 2. 1, the answer is x. The x is, this is telling you what is the independent variable. Minus 7 times 1 over x, minus 7, ln of absolute value of x. Plus 2x to the power of minus 2, we're going to work on this. 2 over minus 2 plus 1, x to the power of minus 2 plus 1. Negative 2 plus 1 is negative 1. 2 divided by that is minus 2. So minus 2, and this is over x. So minus 2 over x and a constant. The integral of 1 plus cosine t dt. First, notice t is the independent variable. So 1 will give you t. Be careful with that, not x. T, because the independent variable is t. Cosine, the derivative is negative sign, but the integral is positive sign. The integral of cosine x dx is sine x plus c. So this is going to give you plus sine t and a constant. What about cube root of x minus sine x dx? To get this one ready, we are going to rewrite it as x to the power of 1/3. And now we can use the power rule on this. 1 over 1/3 plus 1, x to the power of 1/3 plus 1. minus sine, the derivative is positive cosine, but the integral is negative cosine. So minus negative cosine x plus a constant, or you may say the integral of negative sine is positive cosine. Either way, this is positive cosine, but what is this one? 1/3 and 1/4. The reciprocal 3/4. And we can rewrite it in this format. 3/4 cube root of x to the power of 4 plus cosine x plus a constant. We write it in that fashion because of the format it was given. Solve the initial value problem. dp dt is 2e to the power of 3t, p of 0 equals 1. So what is an initial value problem? Any equation containing a derivative is called a differential equation, or DE. In other words, everything that we have been doing, those are differential equations because the derivative of a function was in. A function which satisfies the equation is called a solution to the differential equation. Just like any other equation, the concept of a solution is the same thing. Finally, an initial value problem is a differential equation along with a specified value of the unknown function called the initial condition. So it becomes the initial condition when we add this. So what will this do is that from a general solution, we go to a particular solution. Meaning, for now, we're going to ignore that to see what happens. We're going to completely ignore that. And we're going to work on this by putting the dt to the other side. And integrating both sides. The left side becomes p of t. And we are going to integrate the right. Because it's an exponential, we're going to divide by 3, and we add a constant. So 2/3 e to the power of 3t plus c. So what we have is something we've been doing all along, known as the general solution. So this is a general solution. Why is it the general solution? Because of this constant, you are not looking at one function. You are looking at a family of functions. There are infinitely many solutions. And as far as graphing is concerned, if you graph p of t equals 2/3 e to the power of 3t, the effect of plus c is to take us up and down along the y-axis. It moves the graph up and down, depending on the value of c. And we're done. However, we have this, and that makes it the initial value. Now, that means the independent variable is 0, the dependent variable is 1, the pair 0, 1 normally is x and y. In this case, is t and p of t. So this is t, this is p of t. And we are going to replace it. So 0, we're going to replace the t, 1, we're going to replace p of t. 3 times 0 is 0, e to the power of 0 is 1. Two-thirds plus c is 1, and c becomes 1/3. Replace it. And a general solution becomes one of them, a particular solution. Very straightforward, everybody. So a quick recap, you just integrate, you get a general solution, and one pair will help you get one of those functions. Here's another example. dy dx is 1 over x plus 1 over square root of x. Y is 5x equals 1. This means the pair 1 comma 5, and we are going to ignore for now. We are going to work on this by putting the dx to the right. And we are going to integrate both sides. Obviously, the left side becomes just y. We're going to work on the right to do so. This is fine. We are going to change this to x to the power of positive 1/2, bring it up negative 1/2, or get it ready for the power rule. Starting with the first one. The integral of 1 over x is simply natural log of absolute value of x. This one, we are going to use the power rule. 1 over negative 1/2 plus 1, x to the power of negative 1/2 plus 1, and a constant. So obviously this is 1/2. And this is the reciprocal of 1/2 or 2. This is 1/2 or the square root. Therefore, y equals ln of absolute value of x plus 2 square root of x plus c. And this is a general solution. Infinitely many solutions. And if we didn't have this pair would be done because it would become a basic integration. Now it becomes the initial value because one pair 1 comma 5 is given. And we are going to use that to find the missing constant. So we are going to plug in x equals 1 and y equals 5. This is 0. This is 1. So 2 plus c is 5. C becomes 3. Y becomes ln of absolute value of x plus 2 square root of x plus 3. And this is one of those general solutions, particular solution. In other words, first by ignoring the given pair, we find the general solution. Then applying the pair will help us find one of those functions. This is a family of functions, infinitely many solutions. This is one of those is called a particular solution. This pair will help us get that. That's really the bottom line. Another example, when you find capital F of x such that capital F of 2 is 1, this is a pair, and capital F prime or the derivative is given as 3x squared plus 3x plus 7. So we're going to ignore that. We're going to discuss that in a moment. We're going to completely ignore that. And if we integrate the right side times dx, that's capital F of x, right? So you have to have a dx there, okay? Remember, capital F prime is dy dx in essence. And it's a very easy case of a power rule. You're going to add 1 becomes 3 divided by it, you get x cubed. You're going to add 1, this is 1. When you don't have an exponent, that means the exponent is 1, becomes 2. So 3 halves x squared plus 7x plus a constant. So what we have, obviously, is a general solution. And if we didn't have this one, we would be done. But this means the pair 2 comma 1. So replace the x with 2, y or capital F of x with 1. This is 8. 4. 4 divided by 2 is 2. 2 times 3 is 6. 8 and 6 plus 14. These 3 add up to 28. And C must be negative 27. Replace it here. Capital F of x is x cubed plus 3 halves x plus 7x minus 27. This is a particular solution. That's pretty straightforward, everybody. All right, the integral of x plus 1 over square root of x. To get this ready for the next step, first we're going to change the square root of x to x to the power of 1 half, and we make up two fractions, x divided by x to the power of 1 half plus 1 over x to the power of 1 half. This has the exponent 1. This becomes x to the power of 1 half. This becomes x to the power of negative 1 half. As you can see, so far, we've done simply a bunch of algebraic steps, and now the only calculus step, this one we divide by 1 half plus 1. So we add 1 and then we divide by it. This one we add 1 and we divide by it, and a constant. So this one is x to the power of 3 halves divided by 3 halves. This one is x to the power of negative 1 half plus 1 or 1 half divided by negative 1 half plus 1 or 1 half, and a constant, and we're going to change each one. When we divide by 3 halves, it's multiplication by the reciprocal 2/3. When we divide by 1 half, it's multiplication by the reciprocal 2. If you left it as that, it's not that big of a deal. But since this was a square root of x, please understand, this is 2/3. X to the power of 3 halves means x square root of x. This means square root of x. So we have 2/3 x square root of x plus 2 square root of x plus a constant. It's completely algebraic. This is the only calculus step, everybody. This is the only calculus step. A sample of cesium-137, a radioactive substance, with an initial mass of 79 milligrams, decays T years later at a rate of negative 1.8249 e to the power of negative 0.0231 T milligrams per year. Find the mass of the sample after 23 years and round it to 1 decimal. So what is given? What is missing? It's a radioactive substance. It's going to decay, and the rate or the derivative is given, but the original function is missing. The original function, because we are referring to mass, we're going to call it m of t. So we let m of t represent the mass of cesium-137 after T years. What is given? You can say m prime of t, or dm dt is this one. And what is this one? The initial value m of 0, 1279. In other words, you have an initial value problem, because this, when we go through the process, will give you infinitely many solutions, a family of functions, a general solution, and the initial value will help us find one of those. So if the m dt is this, what is m of t? First and foremost, we are going to put the dt on this side, integrate both. This becomes m of t, the left side. By the way, we are going to go through the process and find m of t, and then we plug in 23. In other words, first m of t, and then m of 23. So M of t is the integral of the negative 1.8249 e to the power of negative 0.0231t. Because it's an exponential, the methodology is 1 over k e to the power of kx plus c. In other words, let's divide by this number. So negative 1.8249 divided by negative 0.0231 e to the power of negative 0.0231t and a constant. Division will result in 79. Now, this is a general solution, everybody. But we have the initial value. When t is 0, m of 0 is 79. We plug in. E to the power of 0 is 1. 79 equals 79 plus c. The constant becomes 0. And m of t is 79 e to the power of negative 0.0231t. I hope you remember with the case of an exponential function, when it's an exponential growth, like y is y sub 0 e to the power of kt. When it's an exponential decay, y is y of 0 e to the power of negative kt in essence. And now that we have m of t, we are going to replace the t with 23. So m of 23 is the same thing, replace the t. Multiply these two, raise e to that power, multiply it by 79. We get 46.439, and always the proper units. It was milligrams per year. This is milligrams. Now, you always write many decimals. This is asking for one decimal only. 4 next to it is 3, doesn't change. The final answer, 46.4 milligrams, is the final answer.